Hey everyone, am I audible to you? Can someone just confirm if I'm audible on the chat? Hello, hello, hello. 43 waiting, that is a good number. कैसे मैं audible? लाइव गया हूँ ना कल बिना लाइव किए तो हुआ यार ये लाइव क्यों नहीं जा रहा हेलो हेलो हाय 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 अरे आवाज बहुत सही बहुत सही बहुत सही बहुत सही बहुत सही हाय 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 ऑडिबल बढ़िया 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 So today we will be having a mock interview. Yes, we have Shivam with us. I'll be waiting for like 5 minutes till everyone joins. Then I'll take in Shivam and we will start. Okay. Come on, Acho. I'm very good. Loved your apartment. Thank you. भाई आपकी शीट की वजह से मेरा Amazon में हो गया निखिल congratulations. Blue Yeti, yes, we got a Blue Yeti. I hope the voice is audible now. How's the weather? The weather is a bit hot over here today, and we don't have fans over here. If you look at the terrace over here, we don't have fans in our apartment. So yeah, yeah. You were about to move table, bro. Which table? I did not move. I felt the background is super classy. I felt instead of having a white background, this background looks better. So I thought of sticking to the background. When is your graph series coming? The graph series will be coming on 20th. Yeah, 20th. Tomorrow is Saturday, Sunday. I'll be full-fledgedly giving like 24 hours, 12 plus 12 in making, that's it, 15, 20 videos. And the next will be on the next weekend I'll make. So yeah, a couple of weekends and I think we should have all the videos up. Cool. Cool. Let's get started. So I'll just take in Shivam into the screen. Hey Shivam, hi. You're not audible. Can you just unmute your mic? Perfect.
या
Shivam.
हेलो भैया.
Hello. How are you?
या बढ़िया.
बढ़िया बढ़िया सब बढ़िया.
हाँ, सब बढ़िया.
तो यार before starting फटाफट से let's quickly have an introduction so that everyone knows about you a bit. Let's quickly have a small introduction about yourself.
Yeah, hello everyone. I am Shivam Vasne and I am currently in my final year and I am from UIT Kurukshetra University and I am a competitive programmer and I am a 4-star coder at CodeChef and I am also a specialist at CodeForces and yeah, and I'm currently exploring backend development.
Okay,
That's it.
okay, okay, okay. That's it. Okay, looks like you're shy enough to give a detailed introduction. Anyways. So are you ready for the mock interview?
Yes, भैया.
So let me just quickly add. Just a minute. Let me just quickly add up your email ID and then we will get started. Just a minute. Yeah, here's your email ID. So, okay, just a minute, bro. Bro, okay, here it goes. So I've sent you a email. Okay, you can find you can find the link. Let me know if it is. I'll share the screen once you have an access to it. Do you have an access to it?
भैया थोड़ा चल मतलब लोड हो रहा है अभी.
Okay, okay.
मेल को लोड कर रहा हूँ.
Okay, sure. You don't need to load your mail. You can just open that link that I gave you. I think that should be fine. The
उस
link
पे
that
भैया अभी रिफ्रेश रिफ्रेश किया है अभी. हाँ, अब आ गया. हाँ, अब आ गया.
okay, perfect. So I'll be sharing the screen now. Okay, let's get started. So we started around how much is the time? 10:05. It's around I think 10:05 is the time. So I'll just share the tab mock interview. Sure. Okay, guys. I hope the screen is visible to everyone, guys. How the screen is visible to everyone, guys. So the question, Shivam, is you'll be given a graph of n vertices, and the vertices will definitely be numbered from 1 is to n. That is something which is for sure. Okay. And I'll also be telling you that the source and the destination for that graph, and the graph you can assume will have m edges. I'll also be telling you about the m edges. Okay, and your task will be, Shivam, to tell me how many number of shortest paths can you have to the destination. Okay, so for an example, assume the source is 1 and the destination is 6 for this graph. So this is the source that I'm talking about. Okay, this is the source that I'm talking about, and the destination is 6. Okay, Shivam. So I can say that the one of the paths can be from 1 to 2, then 2 to 4, then 4 to 6, and that will cost me 3 plus 2 plus 1, that is 6 units, right? And then other path can be from 1 to 3, which is 2 again, 3 to 6, 5 is 1, and 5 to 6 is 7. That will cost me in total of 10 units. But if I take a path which is from 1 to 3, which is 2 units, 3 to 5, which is 1 unit, 2 plus 1, 3, 5 to 4, which is 2 units, that's total 5, and 4 to 6, which is 1 unit, 6 units. So this is containing 6 units. So I don't want the shortest path, I want the number of shortest paths. So over here, we saw that there will be two shortest paths that will be taking a total of 6 units. So I want you to tell me how many shortest paths are there. I hope the question is clear to you. In case you have any doubt regarding the question, you can definitely ask me.
Yeah, okay. ये एक बार थोड़ा स्क्रीन ऊपर करोगे, मतलब उसमें मेरे स्क्रीन वो इमेज लोड नहीं हुई है, मतलब उसमें।
Sure, 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 sure. Here's it.
ओके, मतलब
Yeah.
कि आई हैव टू टेल टोटल नंबर ऑफ शॉर्टेस्ट पाथ्स, राइट?
Yes, not the shortest path. I'm interested in knowing how many shortest paths are there.
ओके, ओके। So I think first I have to find the matlab shortest path from source to destination. Then only I can find the total number of shortest path. So
Okay.
I will I will do simple first DFS traversal from
Okay.
source to destination for finding the shortest path from source to destination. And once I found it, and then I will count how many total paths from source to destination are there, which have the shortest path. So in this way, I think I can calculate this. Uh,
Okay. So you're saying that you're going to do a DFS. So can you
yes,
tell me, using DFS, how will you find the shortest paths?
I will make a visited array so that I cannot, I will not visit the same vertex again. Uh, like
Mm-hmm.
I have to go from 1 to 6. I will do a DFS, and the DFS will be like first I go from all the childrens of 1, which are 2 and 3, and first I go to 2, and then I go to all the children of 2, which are 1 and 4, and 1 is already visited, so I will go for 4, and 4 is, and once I come on 4, I have two options here. Either I will go to 5 or I will go to 6. And
Hmm.
if I go to 5, then it will add 3 plus 2 plus 2, which is 7, and or other option is 6. So this way I am going to 6. And if I go from 5, I have two options. But if I go to 3, then I don't have any option because 1 and 5 are already visited, so I have to backtrack from there. So in and one while backtracking, I will make a जो मैंने visited को true किया है, and I will make it as false because I have to traverse that vertex at some point of time after some point of
Okay.
time.
Okay. Uh, so you will be, in short, traversing all paths, and
Yes,
out
yes,
of all paths, you will be keeping a track whenever you reach the destination about
yes,
the shortest path. If I understand
yes.
that correctly,
Mm-hmm.
right? So what do you think the time complexity will be? Because if I understand correctly, you're going to traverse
Time
all the
complexity
paths.
we go of v plus e.
V plus E. Are you sure about that? Because you're going to traverse every path.
No, I am traversing. I am starting from source.
Okay.
So
how are you avoiding the repetitive calculations? Because you're saying you're going to backtrack and then again you're going to start. So you will be, it will be more than v plus c, because you will be going across every path. Maybe you can take some time, take some
Okay, okay, I
time,
will take some time.
think about shortest paths, and then that will be a better idea. You can use your pen and paper, like it's not
Yes.
necessary that you just look at the screen. You can use your pen and paper if you wish to.
Yeah, I have one thing in mind. Like I'm going from source to destination, and let's say I'm on two. I backtrack. While backtracking, I come on two. So I will store an additional information on two, like from the distance of destination from that particular vertex. So if I have that particular distance, so I can avoid this particular repetition. Like
Mhm.
I'm while backtracking I come on 2, so 2 will contain extra information which will be 3, the distance from that particular vertex to the destination, which is 3. So if I
Okay.
have that particular thing at that particular vertex, then I can avoid my repetition, because this will definitely will repeat, because yeah.
Okay. Okay. So can you explain it in a better way?
Like I have to go from 1 to 6, and
Mm.
I go from 1 to 2, 2 to 4, and 4 to 6. And while backtracking, when I come on 4, I will
Mhm.
store additional information on 4, that the distance from 4 to 6, the shortest distance from 4 to 6 is 1, because I have only traversed only one vertex so far. So I have the sorted distance, and initially I will maintain a maximum value, infinite value to that particular vertexes. So at the matlab,
but
initial time.
but how is that going to help you? Because if you carefully think, if you're storing the shortest distance from 4 to 6, okay,
Yes.
so how's that going to help you? Because
Yeah. If I come at 2 again,
Mhm.
so uh,
because that is the distance between 4 to 6, right?
yes.
So how does that help you? Because you might go from 2 to 4 to 5. So what I'm asking you is, see, you took a path something like 1 2 4 6, okay,
Okay.
and you could have taken a path like 1 2 4 5 6 as well, correct?
Okay. Okay.
Now, how do you make sure that when you take a path like 1, 3, and then you don't go ahead? That's my question. Do you understand what I'm meaning to say? When you start from 1 and you go to 3 and you go to 5, I don't want you to have those repetitive calculations, because once you have already traveled from 4 to 6, 4 to 5, and 5 to 6, the traversal has already been done. If you have a clear view on the DFS, right? Probably I'll give you a hint. Have you heard about some algorithms? You can think about an algorithm which is somewhere related to shortest path. Maybe that can help you.
The discussed algorithm
You
and
can think about that. You can think about that definitely, because the logic that you suggested was, first I'll find shortest path, right? Now,
yes.
DFS will always have repetitions because you're backtracking and again retrying it. So you have to think of something which does not have a repetition. So you can definitely think about that. Probably what you can always do is you can take some examples, and that's the best way to approach a problem. Try to take some examples, and any algorithm that you know or something which you are thinking, try to see. Probably you'll get some hints.
Yeah, like I'm thinking in one way, like if I apply the Dijkstra algorithm, I'm at the source and I'm going to the destination.
Mm-hmm.
So like I'm going from 1 to 2 or 3, so I will update first the distance. uh, at 2 I will create a map, like map, and
Okay.
the at the map I have like 2 3, and I
Okay.
will update the distance of 2 from source to destination. I will 1 to 1 update the distance, and
Okay.
once I reach 2 I will update the distance of 2 and 3, and
Okay.
I will maintain a priority queue like thing, and I will insert 2 and 3 at that queue. So
Okay.
I will and I take the element which is have the shortest distance from source to that particular point from the priority queue.
Mhm.
So this shortest distance is from 1 to 3. So I take 2, and I will mark the shortest distance, uh,
Mhm.
sorted distance from 3 to 5, and which is 3. So I will insert 5 in the priority queue, and I have 2 and 5 both have distance 3. So both have distance 3, so I can pick anything. So if I pick 2, and then I will go to every children of that particular vertex, sorry, 2, 1 to 2.
Mhm.
I will go to all children of 2, which is only single children, which is 4. So I will update the distance of 4 from 2 to 4, which is 2. So I will update the distance from 1 to 4 as 5, because the distance from 1 to 2 is 3. So I will update the distance from 1 to 4 as 5. So,
Okay. Okay.
and I will insert the, I'm clearly applying discussed algorithm, and once I find the destination, I will maintain मतलब कि जो भी शॉर्टेज डिस्टेंस आई है उसके करस्पॉन्डिंग में प्लस करता जाऊंगा.
Okay. So I got a question. Uh, why priority queue and why not queue?
Prior, I have to maintain the priority queue because I have to keep I have to मतलब pop करना पड़ेगा all the element which have the shortest path from
Nope.
source to
I
destination.
My question is, if I use queue, I am sure the answer is going to be same. I'll get the shortest path. If I use priority queue, I'll still get the shortest path. So why priority queue and why not queue?
Yeah, I have like example, one example.
Okay.
Uh,
Are you going to write in the doc?
uh, can I share my screen?
You can write on the doc. It's visible to
Okay,
me.
okay. So like this, one is connected to 3, and one is also uh, one is also connected to 5,
Mhm.
and is connected with 5, and the distance from 1 to 3 is let's say it is 2, and the distance from 1 to 5, let's say it is 3, and the distance from uh, uh, 1 to 3, 1 3 to 5 is, let's say, 7. So
Mhm.
if I traverse 5 first, then I will let me, 1 3 2 1 5 3 5 7. So if I traverse 5 first, then I will update the distance of 1 to 2, the distance from, sorry, 1 to 3 as 10, because I go from 1 to 5, and the distance from 1 to 5 is 3. And if I go from 5 to 3, then I will update the distance of 3 as 10, but the shortest distance from 1 to 3 is 2. So that's why I am maintaining a priority queue. So
Okay. Okay. We can discuss about this afterwards. Probably we can move back to the question. Okay, so we have figured out how to find the shortest path, but the question was number of shortest paths. So how will you approach in the next steps?
okay, so
You can take your time. You can take your time. We still have a lot of time.
Yeah, I have one question like,
Yes.
the uh, is there any case like the source and destination are not connected, like both are lying in different components? There,
No. No, let's assume as of now we don't have any such
okay,
cases.
okay. So that means the path, there is a path, guaranteed path from source to destination.
Okay. Yep. Yep.
So, so I have one thing in mind, like I have the shortest path from any particular point to the destination, because
Mm,
while applying the Dijkstra algorithm, I have the shortest path from every point to the destination. So, uh, if I'm doing DFS traversal and I come whenever like I have the distance from 4 to 6, I have
mm,
distance from 4 to 6, and if I come on 4 from whichever path, which like I come on 4 three times, which
mm,
giving me same distance from source to destination,
mm,
like the distance from source to 4 is like x, and I am coming on source to 4 three times. So the answer 3 will contribute to my answer.
mm, mm, mm.
I'm thinking like this.
Okay.
So like like the distance from 1 to 4 is currently 5. So whichever like if I'm coming uh, three times at 4 from this like I come on 1 3 5 4, like this is also giving me distance 5. So this, so distance from source to 4, there are two ways that I can reach the from source to 4, uh, and it is taking same distance, which is 5. So as this is 2, so 2 will contribute to my answer, and I will not go from 4 to 6. I will directly backtrack because I know this will contribute to my answer. So I will
Mhm.
directly increment my answer from here.
Okay, so you're saying every time you reach a destination, you get the
Hmm.
shortest path,
Yeah.
and for whenever you get the shortest path, you keep a counter and you increment it. If I
Yes.
understand that correctly,
Uh,
if I understand you correctly, is that
yes, yes, we can, like, I like tell, like, can you just matlab, go on the image,
sure?
like the distance from 1 to 4 is 5, shortest distance from 1 to 4 is 5, and
Yups.
the shortest distance through 2, and the
Mm-hmm.
shortest distance from 1 to 4 through 3 and 5 is also 5.
Okay.
So I am coming on 4 through different two different ways,
Hmm.
which is giving me same distance. And
Yups.
I know already, like, what is the distance from source to 4, which is 5. So as I'm coming two times, so I know that both the paths will go to this destination. If both the paths are going to the destination, then both will increment my answer. So
Perfect.
I know, like, these two paths will increment my answer. So I will
Sound
directly benefit from that.
sounds good to me. Sounds good to me. Maybe we can go across and code this. You have
Yeah,
very
okay.
limited time. You have around 10 minutes, not even 10 minutes. I'll just increase the time a bit. So you have very limited time. So I've kept the cursor, okay, on the new page. So probably you can just quickly start coding on the new page. Super quick. Let's see how.
Like, I have to code from main or like from
Uh,
just function.
okay. You just write a function and
Okay, okay.
assume you have the graph in a vector. A vector. Are you in C++ or Java?
C++. plus plus.
Okay, so you can assume that you have a vector of vector as the adjacency list, and you can just code it. Source and destination is given to you. Okay.
Resource.
It's okay. It's okay. It's not necessary that you format it. You can just go on writing. Guys, he prefers writing without any noise, so that is why you don't have an audio as of now. So yeah, there is no audio issue. Map of int, Shiva. Map of int of pending nodes, or
Oh, okay, okay. I will simply contain a set. So, uh, set exactly. Okay, I can simply create. um, um,
you have 7 minutes with you. So let's be quick. So over here, how do you make sure of that stuff that you told me to keep account? I just want to see
Yeah,
that.
I'm just finding the distance first. So
Okay.
after that, I will just simply this is a copy paste like the let's see this
Okay. Okay.
and one second. Um,
Shivam, I think we are running out of time. Okay. So um, uh, no issues, Shivam. I think we can stop over here. Probably I'll explain you uh, how this could have been done better. Okay.
Okay.
Anyways, first of all, good try. That is something which I'll tell you, because coming live, because for everyone watching out there, I think 652 watching, that is a huge number. So Shivam, you got 652 people knowing you today. So first of all, anyone whom I say that I'm going to take a mock interview, there are hundred of people who come across and say yes, we will be there, and there are a lot of people who say कि क्वेश्चन बता दो फिर ही आएंगे नहीं तो नहीं आने वाले. फिर कुछ ऐसे भी लोग होते हैं जो एकदम, मतलब अगर 10 बजे मॉक इंटरव्यू है, 9:30 बजे बोलेंगे नहीं, मैं नहीं दे सकता, बैकआउट कर जाते हैं. फर्स्ट ऑफ ऑल यार, आई थिंक शिवम, kudos to you to come up and give this mock interview. Thank you so much for coming, and trust me, it's not that easy as it looks from outside. So yeah, kudos to you, man. So everyone, can you just give Shivam OP on the chat? And yeah, something that I will share before I move on to the solution. Shivam, some feedbacks that I want to give you as an interviewer is, man, you need to speak out. You need to speak out. 45 minutes were feeling like 2 hours for me. So if that is a feeling that if you give, like, if that, see, solving that, like, you can solve it in your silence, that is perfect. मतलब तुम्हें सॉल्व करने तो 5 मिनट अपने सोचो, वो चलता है. बट अगर तुम पूरा 45 मिनट्स शांत रहोगे ना, समझ रहे हो ना, मतलब पूरा 45 मिनट्स भी तुम कुछ नहीं बोल रहे, you're not even asking for hint. If you're stuck, you need to ask for hints. Even when you're coding, you could have said, see, मैं समझता हूँ, I understand, since you're a competitive programmer, being a competitive programmer, I understand we usually प्रेफर साइलेंस, कि हाँ शांति में सॉल्व करेंगे. सॉल्व करो, 5-10 मिनट शांत रहो, कोई दिक्कत नहीं है. बट जब तुम ये कोड कर रहा था, यू कुड हैव सेड दैट ओके, आई एम गोना डिक्लेयर अ मैप, visited will store this, then I can declare pending notes, whatever. You can at least speak these things out. Otherwise, trust me, true, 2 hours, like 45 minutes was feeling like so long. And if you give this feeling to an interviewer, and at the end, if you don't end up solving, it is somewhere near to solving, you will be rejected. Yeah, it's a different ball game. If you solve it in 30 minutes and you don't speak, it's a different thing. But if you do not speak and you're like on the edge, then you might get rejected. So probably what you need to do is Try giving more and more mock interviews, and in every mock interview tell yourself, I have to speak up, I have to speak up. Okay, that is very 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 important. You need to speak up, man. Okay. And the second thing is, the code quality has to improve, bro. The code quality is something which is in competitive programming, and you need to understand something which you do on code forces or code chef will not work if you're going to interview with Amazon or Facebook or Google or Microsoft or Swiggy or Zomato, Paytm, any of the companies. If you do not improve your code quality, you will be rejected. So something like, I'll tell you for an example, you took map of int boolean as visited. Now I understand in code forces it hardly matters if you take a map or a array, but generally if there is not an use case of map, we don't look over to the map. Instead of that, you could have taken a big of n size array, right? Because you're just marking true or false. Probably you can just taken a boolean size of array. So you need to understand these things, and then again you took this map which is wrong. There's a lot of other things that you need to work on it. Okay. And the second there was a question that I asked, why priority queue in Dijkstra. So instead of telling an example, because these questions the interviewers will throw you in mid of interviews just to debalance you. Okay. Like the moment I did throw that question, you just went off track and you just lost 5 minutes. You need to be smart enough. You just give a one word answer like, okay, to avoid revisiting of notes. That's it. That is what I was expecting. Like your concepts should be that much clear that you tell me to avoid revisiting of notes, and I'm like, okay, this is what I wanted. You can just go across to solving it, right? Again, the second the other thing that I felt was, somewhere down the line you were not well versed with the algorithm, because let's be honest, Dijkstra is an algorithm which is, I think, one of the most frequently used algorithms in graphs. And if you have studied graphs, you should have Dijkstra on your hands. If I ask you to code Dijkstra, you should be able to code it in 1 minute, and you were taking like 10-12 minutes and you still did not complete the code. So that is something which you have to work on. Okay. Cool. Apart from that, I think you are not nervous. You were not nervous, so that is a positive point. You were able to explain your thought process, like whatever you like spoke for like 10 minutes. I understood in one go, so that is again a positive. So you can take these positives. You can probably work on your negatives, and I think you will be very good with some time. Okay, so let's discuss the answer, Shivam. Okay, you have any questions before I move on to the answer?
Yeah, no, sir. No, yeah.
Okay. So, anyways, let's again. You're not speaking as of now as well.
ना
There
ना
are
ओके
then.
नहीं नहीं कोई क्वेश्चन नहीं है ये
Okay, okay, not an issue, not an issue. So, basically, what you need to do is, for everyone watching out. So, the question was stating, you will be given a graph of n vertices, m edges, and a source and a destination. Tell me the number of shortest paths to the destination. So, we need to, like, if this comes up in an interview, you have to be very straightforward. You have to tell that, okay, what is Dijkstra? Dijkstra gives the shortest path. So, we usually use a distance array to store our shortest path. Okay, so now what is this distance of I? So distance of I basically represents the shortest path from the source to the node I. Okay, so what if I can have an array as ways of I, and I can say I'll also compute the number of ways from the source to the node I. Okay, fine. So I can have something like ways of I, and I can have the compute the number of ways from the source to the node I. Okay, if this is something which I have done, now while you always have this thing, right, distance of like node plus distance of whatever node you're like adjacent node that you're taking up, if that is smaller than whatever distance whatever you write in the priority. So this is the condition that you write in the priority queue, right? Over here what you just need to do is, what you always do is pq dot push, you push the stuff in priority queue when you do Dijkstra's algorithm, right? And the other thing that you always do is distance of something equal to this. This is what you do. Now over here, what you need to do is ways of this equal to ways. You have to just uh, you have to just add up the ways. That's it. Because if you're coming from somewhere and that guy took 2 ways to come, you just replicate that. So you just take the ways. Perfect. And there's another thing that you have to take care. If the distance is equivalent, yes, if the distance is kind of equivalent, that means you just need to add it up, like distance of this. You just need to make sure. It adds up into distance of node. That's it. These are the two things that you have to do. You don't need to do anything apart from it. So basically, what I'm saying is, okay, I got someone smaller. This basically means I got someone smaller, right? And ये smaller तब मिलेगा ना जब when I come from a node to somewhere. So if I'm coming from a node to somewhere, that node is what the ways will be. Like if I'm coming from a node, whatever number of ways I can reach that node will be the number of ways that I can reach this particular destination as well, right? And similarly, whether this question is ways to reach destination, I have solved this problem in one of the streams. Well, you can just, I'll tell you ways to reach destination. Yeah, this is not the. So this question is, yeah, number of ways to arrive at destination. This question was, I think, bi-weekly 59, if I remember well. Bi-weekly 59. So bi-weekly 59, if I go well. Uh, yeah, this is the question. And in case you wanted detailed explanation, I have a proper mm, live problem solving. You can check it out. I have explained over here. Okay, in case you want it. Okay, cool. Shivam. Anyways, thank you so much for joining in. And yeah, thank you so much, man.
Okay, भैया.
Okay, sure. Take care, man. Okay, hey everyone. I'll take some questions. Answer where? Bi-weekly 59 live stream is what I've already performed, so you can just check out the answer over there. Yeah, it's basically Dijkstra with DP. So I'll solve this question in the upcoming graph series also, because I felt the question was very good. Because even if you know Dijkstra, you have to have a very decent knowledge of Dijkstra in order to apply dynamic programming to Dijkstra to solve this problem. Okay. And Shivam was a bit sad because he could not solve the problem, but no issues. I'm sure he's gonna do very well. Anyways, any other question? Do you need graphs for? Yeah, obviously you need graphs for SD1 role. Is that even a question? Anyways, any other questions, guys? I'll meet you in July. Okay, by the way, I forgot to say, there is Amazon hiring contest that will be happening. You'll have the link which is pinned. You can check that out and register. ठीक है? Usually होता है यार जब आप इंटरव्यू में आते हो एंड ओवर it's not an interview, it's an interview where 500 people are watching you, तो you tend to go blank, so it's fine. आपके पास नॉलेज हो सकता है, बहुत बहुत ज़्यादा हो सकता है, बट यूजुअली जब आप 500 लोगों के सामने होते हो तो you tend to freak out, so that is okay. It's okay, like you will give 100 interviews. It's not necessary that you're going to crack 100 interviews. So ठीक है, failure will be a part of the process. हर फेलियर कुछ सिखाता है यार. जब आप कहीं फेल करके जाते हो तो आपको पता है, ओके, मतलब अगर मैं आज इस इंटरव्यू में आता, मुझे डायक्स्ट्रा नहीं, मैं नहीं कर पा रहा हूँ, तो आई विल गो बैक एंड वर्क आउट ऑन डायक्स्ट्रा. इट्स फाइन, इट्स फाइन. chill है. Number of ways to arrive at destination is the problem name. 1976. 1976 is the problem number. Okay. Cool, guys. Graph series is coming on 20th. Yeah, 20th, which is Wednesday. I'll launch the graph series. Probably I'll launch 10-15 videos on that day, and the rest videos will come on the next 7 days. Okay, cool. पीछे कौन सी पेंटिंग है पता नहीं यार, रेंटेड घर है, मेरी पेंटिंग नहीं है. What do you think Shivam will crack big tech in future? I think he has the knowledge. He has the knowledge. He just has to get over his introvert nature. Once he gets over that, I think he will be going very high. Anyways, how to revise SD sheet? I told you in the roadmap. I have a roadmap on Striver's channel. I have already told you. ठीक है, तो आज के लिए इतना ही रखते हैं. बाय द वे, लाइक कर दो स्ट्रीम को, अभी भी लाइक बहुत कम है. लाइक कर दो स्ट्रीम को अगर अभी आए हो. एंड थैंक यू सो मच फॉर ज्वाइनिंग, एंड let's meet probably some other day where I'll be solving the jobathon editorial. तब तक के लिए बाय बाय, टेक केयर. See you guys, take care.